kind of my interpretation of what I see as the R&D tax credits from an engineering point of view. So I'll just give a brief introduction to myself and about Mazars, the company I now work for. Talk a bit about the science test, the competency test, what to look out for. An example project is something that I worked on a number of years ago in terms of research, and my kind of final thoughts. So my own background is, I've worked here with Mark and Athlone IT for a number of years, where I was senior research fellow and the director of a research centre. Within that centre, we completed over 1,300 projects for over 300 companies, and we did about 8,000 samples. So after that, there was about 500 medical device companies. So a great spectrum of all the different types of industries that are out there. We understand where research comes from in terms of the industry side as well as the academic side. I've also published extensively in the area, and I've graduated students, and I've about over 5 million in research funding brought in. But as of this year, I suppose January, I decided to have a career change, and I've always had an interest into kind of finance and business development based on a lot of the work that I would have done. So I transferred over into Mazars, but I still am carrying 10 master's PhD students with me, but it gives me a great understanding of what the research actually is. In terms of Mazars, we are 300 people working within the organisation, and that's based in Dublin and Galway, and we're ranked about number 7 in Ireland. And as I said, there's the two offices, but globally there's 260 offices with about 17,000 people, and we have worked for over 100 Fortune 500 companies. So there's a great representation there within the organisation, and I suppose with my background as well, it feeds nicely into it, and I'll talk a little bit more about that. So as an engineer, when I was faced with this job, didn't know what in the name of God to do. But like in any engineering situation, you sit down, evaluate, and understand what is the actual situation. So what is R&D? What's the credits? What can you do? What evolves from them? So we begin by looking at the official documentation that's there from the revenue. And these are the guidelines that are set out, and the language that's used sometimes can be a little bit tricky because it's always open for interpretation. So when I started this presentation, as well as my own study, I tried to create block diagrams and make sense of what's actually going on. But before you can even start R&D tax credits, the important thing to realise is, are you making improvements through known information? It's a no-go. If you're purchasing the rights or the licence, solely. Now, if you're purchasing a license for a part of it, then you can work around that. Tech transfer, troubleshooting, routine analysis. Basically, if all the uncertainty, the science uncertainties have been met, then you can't claim for the R&D tax credits. That's my understanding. So there's different types of research: basic research, applied research, and experimental development. Now, revenue has their own interpretation of what those are. I've just put them up there, and from an academic point of view, it may vary slightly from what you define these are, but we're just going by what research are actually saying, or revenue, sorry. So if we take, there's two components to the R&D tax claims. There's the science test and the accountancy test. So if we look at the science test, first of all, it's built on a platform known as the advancement in the overall knowledge and capability in the field of science or technology. That's one of the fundamental principles. You have to advance the knowledge. In terms of the claims, you need to understand your life cycle, your research life cycle. So all the documentation associated with that you capture it, use it, and be ready to, if an audit comes there, that you have it there available to you. We need to understand the types of research that are available. So, as I said, the basic research, applied research, experimental development. Is this cleared up a bit, is it? Maybe I'll come over here. Is that better? Sorry for that. So we understand the different types of research that are there. So in this particular case, I just looked at applied research. So within this concept of looking at the scientific technology advancement and the uncertainties that exist within your actual project. So you have to be able to know what either of these are. But it's worth pointing out that if the solution is available to a competent professional working in the field, or the knowledge, or lack of knowledge to diligence, this does not qualify or constitute as the R&D. So this is the kind of areas you need to be aware of when you're looking to apply for your R&D tax credits. So the question is, what is these kind of scientific or technology advancements? So I put together a couple of little questions that you can ask yourself. I've just run through a few of them. Has it done before? Has it been published? Is it in the public domain? Did you know the outcomes before you started? Have all the uncertainties been met? And in terms of the software side of things, does it advance science or technology? Are the advancements made through innovations in algorithms, software architectures, and so on? And are the systematic methodologies used? So you need to be keeping in mind all of those principles. And if you can feel that you check all of those, then you're on the road and it was proven in terms of the audits for the scientific advancement. So now we move on to the whole idea of the uncertainties. So uncertainty as to whether a particular goal can be achieved, or uncertainty from a scientific or technology perspective in relation to alternative methods that will meet your desires. Basically, if we think about it, if you've got a project, and most R&D projects are built up of a number of different components, but if you're not sure about one or two of them, and you're thinking, well, if I add 1 and 2 together, I'm not sure of the outcome of 3, or if I add 1 and 3. So it's knowing and understanding, okay, that there is uncertainties within the structure, it's within the research. And this is something that we in Mazars can help you with, to kind of root through this and root through the science and be able to advise you how to move forward. So with all of this information, you've got enough information to put together to go for revenue. The next, and probably one of the most important tests as well, is the accountancy side of the test. James here beside me is the guy with Jerry as well that looks after all the accountancy side of stuff. But fundamentally, there's a lot of stuff that goes on here in terms of qualifying expenditure. But you must be a trading company. All activities must be carried out by the claimant company, except when the subcontracting rules comes into play. You must be qualifying R&D activities, and there must be direct and indirect costs associated with R&D itself. And that is built on these platforms that I discussed for the science test. So knowing the advancement of the science and the planned logical approach, that's already there. So in terms of the actual documentation, if you combine the science test and the accountancy test which is needed, there's 3 possible outcomes for revenue. 1, to reject the claim. 2, revenue approves the claim and repayments in 3 installments, or you can offset the claim against the corporation tax. The third one is revenue questions the claim, and they issue you with 23 different questions. If revenue is satisfied with your response to those questions, then you can proceed and you get your tax credits and so on back as approved. But if they do kind of call an audit, then you need to have your documentation in place, or if they bring in their own scientific advisor, be able to back that up. Revenue also have the right within up to 4 years, or beyond if need be, to look back on the particular claims themselves. So it's important to have all of this documentation ready. And that's something, as I said, this kind of sales pitch from Mazars, that we're there from start to finish to help you with all of these claims and all of these situations if they do arise. Sometimes people, when we've been on the road, they ask us, well, at what point do you stop claiming? And effectively it's when all the uncertainties have been met. If you're not sure of that, give us a chat and we can run through the science, run through the accountancy and say yes or no. And this is probably a good guide to move on forward. So it pretty much fits into this kind of product development phase. Revenue, and a lot of people would say that basic research really doesn't concern themselves with in Ireland too much in terms of industry. It's a lot more applied and experimental development. And it's through the experimental development is where it gets the grey area, it's a bit more difficult. So it kind of devised a plan where we need to be able to understand where your research fits in within the whole product development design phase. And that's something that I can sit down and talk to you if you have any information after this. We can run through a few bits and pieces. So now I'm going to move on to one of my years of research that I worked in a number of years ago. This particular work was looking at the development of an artificial menisci, and I want to use this example to show how research progresses up through. Now this was from an academic background when I was working in the area, and primarily if we're looking at the meniscus, the issues that derives from a meniscal properties must be load bearing, joint stability, lubrication, and shock absorption. So these are the mechanical requirements that are there for the particular body part. Well, you've probably all heard of torn menisci, cartilage damage, and all of that kind of stuff. Effectively, what it is when if your meniscus gets torn, and there's different surgeries that needs to take place from this. So the aim of this project was to develop a load-bearing hydrogel, so it's kind of a polymer plastic system with similar mechanical properties to that of native meniscus tissue, and displays the appropriate levels of biocompatibility. I suppose originally it's because I damaged my own knee and so on, and to move on. So 5 minutes left, sorry. So there's a number of different operations that take place, as well as the marketplace within the area. So if we're looking at the market and we're trying to evaluate where the issues arise, using this methodology we can see that by using a kind of an agile approach or lean approach through the process, we can develop our own protocols and our test standards. So this was the technology readiness level of the project. Sorry, gone too quick there. Over a 4-year period, and it cost 140,000 euros. In terms of the science, these are the different materials, found the best material, done the science part, got the information together, proved that it could resist the kind of stability studies, moved it to the next levels within the process optimization, built replicate models, tested them by 3D printing, measured the analysis, biocompatibility, done trials with clinicians, moved this further with cadaver samples, matched up the entire properties, and what we found is that we had something that worked very, very well. Next stage was we were looking to go for a patent, talked to all the clinicians, I'm sorry I'm going through quick to this, but then moved on to look at the actual market and how much we could take from this particular application. Applied for commercialization funding, and then it all crashed, where there was a breach in contract or breach in confidentiality 2 years prior, where an abstract of this technology had gotten out without my consent, and that was enough to cancel the whole project. Results was we published a number of different papers, but project cancelled. So if I was looking at this in terms of R&D task credits, project failed, but there was an advancement. Answer the questions. Scientific advancement, yes. Taken this model that I built up, science knowledge, elastic responsive systems, 3 of the uncertainties, tested those, proved them, had enough information to submit for revenue. The interesting thing about revenue is they're now paying professionals over nearly up to 1,000 euros a day to come in and review, and this is from the Irish independence since the 1st of January. So it's important to have this documentation in place. So going back to the model that I built up, to avoid this guy, if you have any arguments with him, in revenue, we here at Mazars are there to, from start to finish, to help you in all of the outcomes and the conditions that need to be. So just on that note, I'd just like to say that our goal is to add value to your organisation, and we'd just like to thank yourselves for being here and the organisation committee for having us. And any information, please contact myself or James, and we're down at stand number 23. Thanks very much.